Hi guys, Mr. Rubo here, and today we are looking at number 13 on our test review. So for this guy, it is got our data table and it's got this situation about a study and posted speed limit and number of nighttime accidents. So the thing they first want us to do is use our calculator to go ahead and see if it's linear or quadratic. And then it does tell us to round all of our values to the nearest tenth. And then based on our model, so that equation we come up with, we want to know what it would be if the posted speed limit was 35. So we're going to go ahead to our calculators, and don't mind that. That was a different problem. And I'm going to go ahead and enter these in. And so, yeah, let me just do that real quick. 45, 50, 60, yeah, 70, 75, and 80. And remember, if you do have any extra, make sure you don't forget uh, numbers like 0, right? But then also, if you have any extras, you just hit the delete key to get rid of any ones you don't want. And then let me put the Y values in. So 250, enter. 231, enter. 246, enter. 265, enter. 320, enter. 374, and 430. All right. So now I have to look at the scatter plot. So I'm going to go ahead and turn mine on. Yours may have already been on, so you may not have to do that. You're really just looking to see if it's highlighted in the black, right? So now once you check that, you then go zoom, and then you choose the 9th option for stat, and it'll make a nice window, and that graph is definitely looking quadratic, right? So hopefully we can see that. So now I'm going to go ahead and go back to stat, go to calculate, and I've chosen quadratic regression because that's the way it looked. And with my calculator, I just go to calculate. If you have a different older calculator, you might just need to hit enter. And there we go. We get our equation. So let me write that down. Let's see how well. And they wanted it to the nearest tenth, right? Pretend I remember everything. Yeah, nearest tenth. So I would have 0.2x squared minus 18.0x and plus 669.9. And there we go. So there's our model. So now the last thing we have to do is substitute this in for x. So I'm just going to show the work, but I'm going to be doing it all in my calculator because I wouldn't want to do this by hand. Totally possible, but especially this one is a calculator type question. I would just do it here. So 0.2 parenthesis 35 squared minus 18 times 35 plus 669.9. Hit enter, and it's, according to my thing, it would be 284.9, which 285 is a better approximation because you can't really have 0.9 of an accident. And yeah, if you think about our data, you kind of see like at 40, it was higher than 45. So if you kind of kept that pattern at 35, you would expect it to be a little bit higher. So 285 is our answer there. All right, thanks for watching.